Hi everybody, my name is Mutwana. Let's get started. So before we get started, I want to insist something very crucial, okay? So if you're one of the students who does these modules or these subjects, make sure you leave a comments so I know exactly there are people who need my help as a feedback. But if you don't, then I'm not seeing why I should, because there's a certain group of students who ask me to help them out for this. So leaving the comments is very important. Then I know, okay, there are people who need my help. Means if I don't get any type of feedback in because I make a video for a lot of students, means then I know, okay, maybe there are no people interested in this type of video. So it's very important. Leave a comments and you like, also you share. Comments are very crucial. It's a part of the feedback for me to understand. Let's get started. So now let's say solve this question. This question is very easy. So first and foremost, let's say here determine the question of a tangent at x equal to 1. So what I'm going to do, I have to differentiate. Differentiate is way easy. So let me find f prime. So I'm going to say find f prime first. F prime meaning function. So say find f prime. So look, this is quotient. So since this is quotient, means the numerator one, let me call it f, and the denominator is g. But when you differentiate f over g, means if you take f over g prime, meaning write your denominator constant and then differentiate the numerator. Sorry, I say the other way around. Okay, numerator must be constant and then differentiate the numerator. Minus now, numerator is going to be constant now. And this is going to be constant now. No, what am I saying now? Okay, put the denominator constant, which is g, constant, then differentiate the numerator, and then now reverse the process. But you must start. Okay, just simple as that. So now, and then we square the denominator. So what is our g? G means the denominator. So I'm going to say now f prime equal to, so we say denominator constant. What is the denominator? Denominator means square root of x plus 1, x squared plus 1. Denominator of x squared plus 1 means this constant. And then we differentiate the numerator. So differentiate numerator. What is numerator? Numerator is x for this case. Minus, now we have to reverse the process, means now the denominator is going to be differentiated and then put the numerator constant. Means numerator now is going to be constant, then we differentiate the denominator. But what is the denominator? Square root of x plus 1. But that same as say square root of x plus 1, and then we over denominator square the denominator, which is called denominator, means take this x squared plus 1, and then what you do, you have to square the denominator. So now we're going to say, okay, prime equal, okay, now when you derivate x is going to get to 1, so it's going to be all of these times 1 is going to be the same thing. Now we minus, we have our x. Now let's differentiate all of this. You can differentiate the side, so you can say, okay, let's differentiate the side. Remember, that's like a differential of that. But what does that mean? That means like x squared plus 1 power half. Square root means half. Now let's differentiate. The half is going to go to the back, and then differentiate what is inside the bracket, means this is going to give us 2x. And then differentiate all of this, means this one went to the back, and then we differentiate the inner one, and then we minus 1. Then when you minus 1, it's going to be x squared plus 1, right, exactly, half minus 1 equal to negative a half. So this let me say 1 over 2. We can just simplify this one. Let's simplify this, okay, by 2, 1 by 2, 1. So now we have on top, you have your x over, take all this denominator because it's positive, so it's going to become x square plus 1 is become positive, means it's going to become positive a half at the denominator. But what is positive a half means is square root, so I can simply say square root. So when you differentiate all of this, you get that. So then I can simply write x square root of x plus 1. But make sure you show this is a part of the solution. So this can be 1 over, no, is x is not 1. Is x over square root of x plus 1. Okay? So also make sure you make it part of the solution. Okay? It's very crucial. And then we over. Oh, okay. My computer is kind of freezing a little bit. Okay, so we're gonna say now, it's just my computer kind of went forward a little bit, but I'll rewrite it. Okay, so we had this statement here, right? Just a second, people. My computer kind of went forward. So we had, so we say f over g prime equal to denominator constant, which is x squared plus 1, and then we say we differentiate x, which is going to give us 1. Sorry, my computer kind of froze minus. Now this we say we write the denominator now constant. Now we say we write the numerator constant, and then when you differentiate that, we got x over square root of x squared plus 1. Sorry about that, because my computer, my PowerPoint went off. So we square the denominator, which is going to be x squared plus 1. But what you have to do, you have to square. Simple there. So now let's simplify. So what I'm going to do is say x times x is x squared. X times x equal to x squared. Okay, so x times x equal to x squared. Oh, so this one here is going to be exactly how it is. Minus x squared over, my PowerPoint went off, so but you understand what is happening here. When you square this, it's going to give us, means this and this is going to cancel, so denominator is going to be, no, there's no root here because this and this cancel, so just x squared plus 1. So what we can do now, we can just say over 1. Remember this f prime, right? So we can say over 1, and then we can cross multiplication because we want to find the common denominator of the one on top and simplify. So this is going to give us, look, if you have a this times that, it's like somebody gives square root of x times square root of x. What you going to get? You're going to get x. See? So now if we take this square root of x plus 1 times square root of x plus 1, it means you're going to get x squared just plus 1. No root anymore. So we minus 1 times x squared, it is x squared. And then over, we multiply these two here. 1 times that one is going to be x squared plus 1. But remember, all this is denominator over this, which is this one here, which is x squared plus 1. You see what I'm saying? So then, make sure you show your works, okay? So then we say, this same say, can just make a space here. So then you can take this one here, acceptable mathematics. But look, if you open the bracket, this and this is going to cancel. So I cancel, oh yes. So that means, because it's going to be x squared plus 1 minus x squared is going to be 1 over, we can bring to the top. But when this is same as say, it's 1 times x squared plus 1. You can do like this. Times that. So this same as say 1 over, but look, when you say x squared plus 1, it's like x. It's like somebody give you x root times x. What does that mean? This is like x power half times x power 1. This times x 3 over 2. Because the bases are the same from the exponential rule. So now we're going to say this half here is going to become x plus 1 power 3 over 2. Because there's a square root of x times, which is x. They are the same thing. See? So we're going to say then, if this stuff come here is going to give us, it's going to become 1 over that. So these are f prime. See? Which is slope. So our slope, m, or f prime, equal to 1 over x squared plus 1 power 3 over 2. But, listen. We got our slope. Let me write here aside because we're going to use it now. So our slope, I can say our slope f prime equal to 1 over x squared plus 1 3 over 2. That's our f prime, or you can call it slope. Now let's come back here to the equations and get it done. It's easy, man. This question is very easy. Look, they say here, determine the equation of a tangent at x equal to 1. Oh, so we can get a slope phase. So we have a slope. We can call f prime, but at x equal to 1 equal, let's plug it, it's going to be 1 over x equal to 1. 1 squared equal to 1, 1 plus 1 equal to 2. 2 power 3, 3 over 2. But mathematical, that's the is 2 on top. Okay, let's write down a little bit. So I can say this is the same as say our f prime, but of x equal to 1. Or sometimes we can call it slope. Equal to, let's plug x equal to 1 over 1 square equal to 1 because x equal to 1. 1 plus 1 equal to 2, so it's going to be 2, 3 over 2. But what 3 over 2? 3 over 2 is like 1 over 2 times 3. So I can just say, same as say 1 over 2 times 3 is a power. So this same as say, let me write here, 1 over square root over 2 power 3. So this is going to be what? Slope. So this is our slope here of a tangent. Okay? So if you got your slope of tangent, they don't want a slope of tangent, they want a equation of a tangent. Make sure you write everything, people, okay? They want a slope of a tangent. Easy. Why do I say easy? Look. So I'm going to say, see, this meaning is 1, look, power 3 is like square times square root over 2, because this is like power 1, this is power 3. It's like a 1 over 2 square root over 2 is our actual slope. So slope of tangent we have. But I want to get a equation of a tangent, which is easy, okay? So let's find the point of a tangent. Point of a tangent. Look, when x equal to 1, let's substitute in the original equation. When x equal to 1, what the value of y? Put this 1 in here. So it's going to become, look, 1 over x 1 square 1 plus equal to 2. Oh, so it's going to become what? 1 square root over 2. See? That's a point of a tangent. So for that case, I have everything. So I can go to the equation of a line, which they say y minus y dash equal to m x minus x 1. My apologies, people. Oh, I need to put my phone in silence. Sorry about that. Let's put it in silence quick. See? So now I know my x and I know my y. So I can simply substitute to say, okay, y minus y dash. Y dash means this value here. 1 square root over 2. Okay, m. Slope we have. Slope equal to 1, 2 square root over 2 x minus, what is that x? X equal to 1. That's the equation. If for 1, I can rearrange. If for 1, equation of a tangent is equal to y. Okay, I can multiply this out. So it's going to be 1 over 2 square root of, no, 1 just square root of 2. 1 square root of 2 equal to 1, 2 square root over 2 x minus, multiply that out, 1 over 2 square root over 2. So what we're going to do now, we're going to take all of these minus that one to the positive. So then it's going to become y equal, oh, space is not enough. Let me erase here on top. Okay, but when you write everything like the way how we flow. So we're going to say y equal to, okay, here we have a 1, which is this one, 1, 2 square over 2 x, okay, minus 1, 1, 2, 2 square root of 2 square root of 2. And then this half here is going to go to the, here is going to become positive what? 1 square root over 2. So you can just simply say y equal to 1, 2 square root over 2 x. So we're going to plug down the calculator, take a calculator. And then we're going to say fraction 1 over 2, and then square root over 2, square root over 2. And then that's minus. And then plus 1 over square root over 2. Square root over 2 over 4. Okay, this is going to give us positive square root over 2 over 4. So this is equation of a tangential, equation of a tangential. See, we got equation of a tangential. If you want to make it linear, you can make it linear. It's up to you, but that's the equation of a tangential. Now, in our tangential point, we have our tangential point. We which is this one here. Now, what do they want? Now, they want a question of a normal now. Question of a normal, which is way easy, question of a normal. What I'm going to say now, remember, if we have information for tangential and normal are perpendicular to each other, meaning, look, if I want to get a question of a normal, I must do this. Y equal to slope, but now since the normal means you must have to say slope of a normal. Let's say slope of nx plus c. It's like mx, but that slope must be slope of a normal. Okay, so let me show you quick another method that you can do for the second one, okay? So now we say, look, so we have equation of a tangent, which we got, equation of a tangent y equal to, equation of tangent equal to 1 x square root of 2 x, and then you plus square root over 4, square root over 4, sorry, square root over 2 over 4. Let me show you another way that you can find the equation of a normal, or the easy way. So what I'm going to do, look here, this is very, very crucial. If you have we have a slope of a normal. Slope of a normal always times slope of a tangent equal to -1, always. So slope of a tangent, we have this one. So we say slope of tangent equal to 1, 2 square root over 2 times slope of a normal. Slope of a normal, we don't know. Times slope of a tangent equal to 1 over 2 square root over 2. And then we say equal to -1. You know why we multiply equal to -1? Because they're perpendicular to each other. Normal and tangent, they are perpendicular to each other. That's why when you multiply, their slope equal to -1. So now slope of a normal equal to, we multiply this on this side. It's going to give us -2 square root over 2 over this 1. So this is slope of a normal. So then we can just finish up. Okay, so we can just finish up. So we can simply say y minus y1 equal to slope of a normal for this case, and then we say x minus x1. But remember, x1 we got equal to this one here. But the problem, we don't have a y1. So take this value of x and substitute in here. So it's going to be f of 1 equal to 1 over, plug 1 square equal to 1 plus this 1 equal to 2 square root over 2. Oh, so when x equal to 1, y equal to 1 square root over 2. So now we're going to say y minus value of y1 equal to 1 square root over 2, and then equal to slope, we got slope of normal, we got -2 square root of 2 x minus x1 equal to 1. So we can simply simplify and get the equation of a normal. So equation of a normal equal to, here's minus, okay. So I can just say, let me multiply by, because I want to make it linear, multiply by square root over 2 throughout for each one. So multiply here by square root over 2, because I don't want this at the denominator. Like if somebody, I think you understand, this is basic, multiply by square root over 2, multiply by square root over 2. So this is going to give us square root over 2y, this and this is going to cancel, minus x equal to square root over 2 times square root over 2 equal to 2. So 2 times -2 equal to -4 x minus 1. So then I can simplify that, and this is going to give us y minus x, y again minus x from, I'm wrong here, sorry, my apologies. I'm sorry. You must be laughing at me like, oh, you made a mistake there. Okay, look. So square root over 2 times 0 is going to be 2y. Oh, sorry. Square root over 2y minus. Okay. So this one here and this is going to cancel, just -1 equal to. This will say equal to -4, because when you take square root of 2 times square root of 2 times -2 equal to -4 x minus 1. I was just silly. I don't know where did I get that x from. I was wrong. Okay, because you say you multiply by -2 throughout this, and this is gonna cancel. Okay, so now this is gonna give us square root over 2y minus 1, and then equal to, multiply that out, -4 x plus 4. This negative is gonna go over, so finally it's gonna be square root over 2y equal to negative 4x plus 1 and 4 is going to give us 5. This is going to be equation of a normal. So that's going to be equation of a normal, and that's going to be the end of the equation. And look, like I say, writing the feedback is very, very important, because when you leave the feedback, then I know how many people help, or these students need help. Okay, so leave the comments. It's very, very important. Let me know if this video helped you, so I can continue making video like this. Thanks a lot. Peace and I'm out.